So example 1, topic, right? Topic, we are going to be doing solving proportions, which is a fancy way of saying a fraction equal to a fraction. Good. So solving proportions is a fraction equal to a fraction. And if I look at example 1, it really is a fraction equal to a fraction, okay? And the easiest way for us to solve it is this whole thing called cross multiplication. So I'm going to take the 9 and multiply it up there. And I'm going to take the 45 and multiply it up there. So I just take and go, right? That's all I do. Take the bottom parts, the denominators, and multiply them up, okay? So it will change to 4 times 45 equals 9 times x plus 3, okay? So the fraction's gone. It's called cross multiplication. Take the denominators, multiply it up and over, denominator up and over, okay? And then we're just going to finish solving. So 4 times 45, I don't know what that is. Let's find out real quick. 4 times 45, 180. Yeah. 180 equals 9x plus 27, right? Minus 27. Minus 27. If I get going too fast, will you tell me, please? Okay, that's what I want to hear. I'll let you catch up, okay? So I cross multiplied. And then to simplify it, I went 4 times 45, which is 180. I distributed, okay? I'm going to go minus 27 minus 27. Get 153, and then I'll just divide by 9. And x equals, I'm going to divide by 9, 17. Okay. Okay. Easy. You could have probably shortened it here. If you wanted to divide by 9 first, it would have shortened it, but that's okay. I just throw tricks out there. Okay, example 2. Ooh, words. We can do words, though. We can do words. All right. So a college brochure states that 11.5% of the students attending colleges are majoring in engineering. Okay. If 2,400 students are attending the college, how many are majoring in engineering? Okay, so what we can do is this. We can set up a proportion. There's several ways to do it, but I'm going to set up a proportion, okay? So I know 11.5% is the part out of 100%. You okay with that? 11.5, and then what I want to do is that we'll have engineering students. We'll call it X, or X for the engineering students, over my total, 2,400, okay? So this is one way to do it. And of course, there's several ways to do this problem. Just multiply by 0.115, I know. But I'm going to try and set up as a proportion. So in a sense, what I have is, you ready? I've got the part over the whole equals the other part over the whole. Okay? So that's kind of the way I did this problem. Okay, 11.5 is part of the population, and 100% is the whole population. That would make the engineering students part of the population, and the 2,400 be the entire population. See, part of the population and then the whole population. Well, if I just cross multiply, right, that times that times that, I get 11.5 times 2,400 equals 100x, right? So I'll just multiply that, 11.5 times 400, hold on, 11.5 times 2,400. So I have 27,600 equals 100x, right? Then if I divide by 100, I get 276. Engineering majors. Okay? A faster way, probably if you're good at percentages, would have just to multiply by 0.115. Anybody do it that way? Yeah, it's the faster way to do it. But this kind of shows why. Okay, how am I doing? Okay? Okay, example 3. So a pedometer measures how far a jogger runs. To set a pedometer, read a nose, she must know her stride length. Okay, so Rita counts 328 strides. And she runs once around a 400-meter track. Okay, so a meter's about 39.37 inches. Okay, how long is her stride? So she's got. So let's find out how many strides it took for 400 meters. Okay, so she took 328 strides, right? If I divide the 400 by that, I could find out how long her strides would be in terms of meters, right? Does that make sense? Take the 400. I mean, you're going to run around the track. You're going to count how many strides. You're going to go 1, 2, 3, 4, 5, 6, 7, 8. They go, well, how long is each stride? Let's take the 400 and divide it by the 328, and that'll tell us how long each stride has to be. Does that make sense as a proportion? So I'm going to, okay, I can do that. I can clear and go 400 divided by the 328, and I get about a 1.1295 approximately meters, right? All right, so here's a meter, right? So she's moving pretty fast because she's jogging. She'd never have a she's like Keisha. She knows how to run the 400. She can go, right? So, I mean, you know, because Keisha, if you're jogging, your stride length will never be that long, right? For the 400, you got to have a good stride length, right? Yes. Definitely, okay? So, you know, this Keisha's stride, we'll call this Keisha instead of Rita. It's about that long a stride length, so it's definitely a race, right? It's got to be a race. So, then, that's a great answer in terms of meters, but since we dummy Americans don't live in a meters world, we want to know, how many inches is that? Well, then we're going to take our 1.1295 times our 39.37, right? Find out how many inches she's got, okay? So times my 39.37. And so she's got about a 48-inch stride. Yep, it's definitely a race, isn't it? Because if you're jogging, you'd have a lot shorter stride length. It says jogger. I don't think she's a jogger. I think she's a runner. Okay, turn the page. Does this make sense? All right. Oh, it looks like geometry. Remember doing these in geometry? It does. Okay, so ABC has vertices at 0, 0. Let's call that A. B is at 8, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. There's B. And C is at 8, 0. Okay? Draw my triangle in. This is actually very easy. I don't even know if we need to do it as a ratio. So E is at 2, 0. Here's E. We know the triangles are similar, so they're going to have the exact same shape. Remember that? So my guess is that this little orange triangle's got to be the triangle they're looking for, right? See that little orange triangle there? If E is sitting right there, then we want the other triangle would be the orange one. So my guess is we'll call this, how about D? Okay, that's D, A, D, E. So the coordinate of D has got to be at 2, 1. What's the ratio? How am I doing? Am I going too fast, Megan?
No.
Okay. What's the ratio between the two triangles? What's the ratio between the two triangles? What's the scale between both triangles? 1/4, 4/1, same thing. Yes. Yes, yes, yes. The ratio is 4:1 or 1:4, same thing. Nice job. Or 2:8's easier to see. 2:8, you guys see the 2:8?
Wait, how did you get that?
Great question. So let's take a look at the little orange triangle. It has a length of 2, and the big triangle has a length of 8, right? So if I go 2:8, that's the same thing as 4:1. Or this big triangle is 4 times as big as this little one, right? Okay, great. All right, example 5. A rock climber wants to know the height of a cliff. The climber measures a 4-foot shadow of a 5-foot friend and measures the shadow of the cliff. Okay, the cliff shadow is 60 feet. How tall is the cliff? This is just like geometry. Remember doing this? It's easy. So let's put a rock. Here's a rock wall up there. All right, I like that. There we go. We're going to try and get to the top of that. And then it's got a shadow. All right, here's the shadow. Cast the shadow, right? And this is a 60-foot shadow. Now we got a friend. If he stands right in the shadow, right? Here's my friend. And my friend's 5 feet tall and casts a 4-foot shadow. So let's see what we got. Hopefully you guys remember this from geometry. We have 2 triangles. I've got my little blue triangle, right? And I've got my bigger cliff shadow, right? Right. And so let's call this X for the cliff, okay? So we've got a couple of ways to do it. In proportions, you just have to be consistent. I can go cliff height, boy height, cliff shadow, boy shadow, okay? I could do that. I could go, okay, so that means I could go X to 5 equals 60 to 4, right? I could also go little shadow to big shadow, little height to big height. Just as long as I'm consistent, it doesn't really matter. I can do all sorts of different ways to set this up. It does not matter. As long as you set it up so it's consistent, okay? So, I don't know, the easiest way is to go, because put the X on top. Let's go cliff height to boy height equals, you ready? Cliff shadow to boy shadow. So in words, what I put was cliff to boy equals shadow of the cliff to the shadow of the boy, okay? So using words. Sorry, it's so sloppy handwriting. But, you know, be consistent. Then just cross multiply, right? Remember, cross multiply that times that times that. So let's go a 4x equals 300, right? If I cross multiply, 75, right?
Yep.
X equals 75, and that's in terms of, is it feet? Yeah, feet. It's got to be feet. Okay, so pretty easy. So our homework, back on the front page, page 100 to 12, 13, 22 to 28, all. It does say all. And then it is only 10:34, so we got lots of time to get things done, right? Getting our homework done and our balloons, okay? All right, yes?
Couldn't the triangle be trans